Hello friends, welcome to the channel. If today is your first time visiting with us, we want to extend you a very warm welcome and to invite you to look around our 326 videos, as we feel confident you're going to find something you enjoy and you find useful in your personal life. If you have been here before but you have not subscribed, what are you waiting for? Please subscribe. If today is your birthday, we want to wish you a very happy birthday. Today we're going to discuss basic electrical work, so stick around and see if we can give you some tips and some information maybe that you do not know. Alright, most electrical projects start with electrical cable, and this is the typical household rated electrical cable. This is Romex and it is 25 feet, and we're going to use it to make a run to power our newly installed water softener that right now we're powering using an extension cord, which is not ideal and not correct. However, this will be kind of unusual because we're not going to make a permanent connection, even though we are going to create a normal jack. We're going to have it with a plug. So if we ever move out of the house, we are going to take that with us, and this way it is semi-permanent. It definitely meets code. It doesn't need a conduit. This is rated for inside use. And in the process, I wanted to show you a couple of things that you should know if you want to do your own wiring. So typical Romex for 120 volts will come with 3 cables, and for 240 volts will come with 4 cables. The 3 cables will be black, which is the live wire, white, which is the neutral, and an exposed wire, meaning without any sheathing around it, which is the ground, and it is actually copper. In a 240 circuit, and I don't have a wire to show you, but there will also be a red wire, so you're going to have 2 hots, the red and the black, a neutral and a ground. So the first thing you have to do is to expose enough cable to do your I really love this thing. And as you can see, now I have exposed my cables. I really like this tool because with one movement I can take care of all the cables. When you look at household rated plugs, this is a standard plug.
Can you slow down your movements? You're very jerky and all over the place.
This is a standard plug, and when you look at it, it's going to have 2 sides, a brass side and a silver side, and also a green screw, which is actually the ground. Now the black wire goes on the brass side, and the white wire goes to the silver side. And also, if you look between the two, there is a bridge that connects those 2 screws. So if you want this receptacle to be always on, for example, and provide power to both receptacles, you just need to put your cable in one of the 2. However, if you want, for example, to power one of the receptacles with the power switch, you can cut this, I don't know, can you see it? You can remove this little tab and wire the receptacles independently from each other. We're going to wire this, even though we really don't need it at this moment, but we will for demonstration purposes. I think I need to take a little more of this.
You want to go slow and demonstrate that too?
I don't know. Do I need more, you think, or we're good?
I think, honestly, you're probably going to need a little bit more. But...
Now you can make a loop and plug the wires here through the little screws, but a lot of the most modern receptacles will also have in the back holes. Yeah, you can simply insert the wires. Sorry. And inserting the wires is the path I'm going to take today. However, for the neutral, you don't have this option. The neutral always is a screw. So all I'm doing now is putting all my screws in so they're not in the way. And again, I need to take my black wire.
Can you show us where you actually press them in?
You see there's a hole there?
For those who are not familiar with this process. Okay.
And if for some reason you need to take it off, right next to the hole, you see this slot? You put something in that slot and releases the hole. So here we're going in, you see that?
Yep.
And let's see if it's going to lock. And as you can see now, it is locked, but I need to take a little more of the plug sheathing because it doesn't go all the way in. Now the easy way to find how much you need, actually, there is a way to do that. I just thought I had enough. And that is to put it here. There is a little bridge, I don't know if you see it, a little ledge. Is it visible?
Yep.
And that's how much you need to cut. And that is good. Now we're going to the white side.
You're gonna need to take some off that one as well.
You think? Nope. But I might need to cut this, and I don't know if I can. Or maybe I can have just enough to do the. Now usually you will do this process with this inside a receptacle. In our case we're going to actually use that receptacle we're going to place it by gluing it on the concrete wall or putting it in the rafters. I haven't 100% decided. But this is, and you can see, the correct way to wire a receptacle. Now, as you can see, there are 4 holes, not 2, and that is for the reason I said before. If you break this tab between the 2 screws, then you can wire it again to do 2 different things. For example, you can wire one of the receptacles to be constantly powered and another receptacle to be controlled by a switch. And you can see the other set of plugs has also the holes and the tabs. Right? Now, if you're concerned about electricity, if you're afraid about electricity and electrical connections, this is something you shouldn't play with. Here, of course, this is not connected to anything, but goes without saying that if you're doing any additions, any receptacles, you will have to cut the main from your house, or at a minimum the circuit you're going to be working on. And I'll see if I can actually show you how to wire the actual plug.
And by cut the main, you mean to
Interrupt the electricity.
interrupt electricity. Yeah.
And this is just a standard plug. And I'm going to take it apart and go on the other side and show it to you. I don't know if I want to do that because I will have to take it apart for us to install it, and I'm not ready to install it today. But I'm going to show you at least. And as you see, this is just a clamp that will allow you to put the cable in the controller. I'm sorry, not the controller, what you call this thing? The plug, not the plug. What is this thing called?
Housing?
No.
I don't know.
I have a brain for it, guys. I don't know what. I guess this is a plug, right?
Connector. We're calling it a male connector.
Yeah, it's a male plug. Yeah. It is what goes into your receptacle. And again, our receptacle in the basement is too far away from our installation. So we're going to create another one, and as you can see, they mate each other, right? Too fast? On this specific one, it just needs to take 384 screws off.
384.
Well, don't you see how many screws have to take off?
No, you need to show us. We
There are 3 screws here.
Uh-huh.
There were 2 screws on the clamp side.
So 384.
Yes,
Okay.
that's what you've got in my electric screwdriver. I decided to go manual, but I'm regretting that decision. Why are you laughing?
It's 5 screws.
It's 5 screws
This
that...
takes me back to yesterday walking around the store. We were in the analog department and no, had to go to the digital department.
It's 5 screws that you don't have to unscrew.
I wouldn't care if I had to unscrew them. But I'm not doing this demonstration, you are.
Yeah, and I'm using an archaic tool,
Oh my
a
gosh. We need to get rid of all the manual tools.
manual operated tool, no. And as you see, we have the same color setting here. So we have a green ground, and we are going to connect our ground from the other side of the cable here. We have a silver, which is our neutral, that means the white wire. And here we have a black. Even in receptacles, it will be either brass or black. But the black is our live and matches our cable color. So we have the black, the white, and the neutral. And these are just with screws, you cannot press them in. And we're going to show you in another episode exactly how this is going to work. I just wanted to show you today the basic of electrical work. Again, safety with electricity is very important. You can kill yourself if you're not careful. I recommend that you have some device that you can plug in, even a light bulb if you have nothing else. And make sure, let's say that this was a live receptacle on the wall, right? Having a device that you can plug in to make sure that it is not alive, it's a very good idea. Also, there are very inexpensive devices that you can buy that can detect live circuits, and you can solve those. Let me see if I can show you. So there are several devices you can use to test for live circuit. These two are 2 examples, and we're going to go in another receptacle and show you, because of course this is not live, right? But you can go in front of the receptacle and it will show you if it is live or not. And if you do your own wiring, this device, am I going still too fast? This device actually will tell you if you have wired it correctly. It is very simple, it is color coded on the top and it tells you if it's wired correctly or not. And simply all you have to do to use it is plug it in. And if you plug it in, of course we have nothing here, but then these lights will tell you if you have done your wiring correctly or incorrectly. For some devices this is critical. For a light bulb it isn't, because a light bulb will work even if it is incorrectly wired. But electronics and things like that, this is a nice little device that you can have. And if you have a CFI circuit, and ground fault interrupt is what CFI stands for, ground fault interrupt, and they are intended to protect you against electrocution in places that might be wet, might have like a bathroom or outdoors. And if you want to check that the CFI works correctly, this is a device that does exactly that. You plug it in, and there is a button on top that says test, you click it, and that in essence creates a sort that should trip the CFI. Right?
Is it GFCI? Ground fault circuit interrupt.
It is both. I mean, it is referred to as both.
I'm just asking.
Well, the ground fault is kind of superfluous because, you know, circuit fault interrupt is what it does. The ground stands because it does it through the ground. As I said, it sorts. In essence, it will sort between the green and the black. So it will sort between those two.
Okay.
And that should trip it and kill the electricity to this receptacle. Now, electricity will still happen here. It will still arrive in the terminals, on the cables, right? It doesn't trip the fuse. It only trips the CFI.
And we can demonstrate that because we have some of those outlet receptacles.
Yeah, I'm not going to trip it, but we can demonstrate it. So let's go and show you how those here, that there are no electricity, nothing happens. But the moment I go, and it's actually very sensitive as you see, right? The moment I go to somewhere that there is live electricity, you immediately get it. You immediately get it. It is immediately active is what I wanted to say. Maybe I turn it off and it was on, I don't know.
Something not bad. Oh, there you go.
So these are very nice devices that apparently have to be on to operate.
Do you want to show them an outlet?
Yeah. And again, now you see from the outside, this is the black, right? And this is neutral. This is a little more sensitive, as you see, it doesn't pick it here, or this will probably pick it all around. No, this doesn't either. And again, it picks the live, and it doesn't pick the neutral because the neutral has no power, right? So this will be our white, and this will be our black. And this is an example of a GFCI receptacle. Again, you see the live, the neutral, the live and the neutral, and it has a test button. So let's, we're going to turn things off, so I'm not going to do it. But you can hit the test button and reset it, and if you hit the test button, it's going to cut the power to this. The problem is that the way those receptacles are wired are to protect other receptacles downstream. So if the electricity comes from this way and continues that way, does it make sense? If it's live here and from here goes on, and you can see it's live actually there, and it doesn't send anything here, then if you trip this, it's going to trip all the other connected devices that are downstream.
Which we had an experience with recently.
And we couldn't find because our house is wired by gremlins. Am I wrong?
Drunk electricians is what it
Drunk
was.
electricians and gremlins and things. Anyway, I want to show you another device, and this is a very, very useful device that allows you to measure electricity that passes through a cable without actually having to do anything but open the jaws and just put it over, and then the display will show you what your voltage is. Of course, here it won't show you anything because we're off.
Not connected to any power.
Right, we don't have any power. We're powerless. Without power. And this is very much like the old style meters, like this one, and it can even be used as one of these. If you work with electricity, you definitely need something like that. And as you can see, it has places to plug the two probes. You see that? So it's like one of these, but even safer because you have like an exposed wire somewhere and you want to see if it is alive. All you do is open this, and you can even, you see it has contacts here. I don't know if you can look at the jaw. You see the metal contacts?
There's the focus. Yep.
And so you can actually go and touch it. And it is both inductive and conductive electricity, and that also will give you a reading. So this is just a short primer. What I recommend you have if you want to do your own wiring is one of these. You can find in virtually every store, Walmart, Target, Home Depot, Lowe's. We are not sponsored by anyone. I'm just saying these are fairly easy to find.
What is it called?
It is a circuit connector tester. It allows you to know if these connections were done correctly. So if I've put the black on the wrong side, this will tell me that I did it incorrectly. So especially when you start, if you're not sure, checking with one of these devices can be invaluable. So I will have one of these for sure. One of these, which again allows you to see if a circuit is live. Again, if you see here, we have no electricity, so nothing is live. And of course, nothing will ever be live in the circular part of a plug, because this is the ground. And I will definitely have even an inexpensive meter. Maybe in a different episode we'll go over how to use one of these. And I can tell you that I totally love this. Actually, I might put it downstairs if you want to purchase one. It is the easiest way to strip wires. Wouldn't you agree?
Yeah, and all the wire tools that we have,
It is a lifesaver. We have the traditional ones and they are a pain. These automatically adjust. You don't even need to know how much, what gauge wire you have.
Yeah.
And if you need to know how much to take, it even has a little scale here. I don't know if it is even visible. It's probably difficult.
Just give me a second. Yeah, okay.
And that allows you to decide how long of a clearing you're going to do on your cable. So this concludes our short introduction. Of course, you need a plate to finish the job, right?
Yep.
And I guess I forgot.
Okay.
All right, do you remember what they are? Two yellows means that it's correctly wired. Any other combination means that it is not. And this is a table that tells you what is incorrectly wired. And the most important one is if you have reversed the live, the hot and the neutral, and also if you have reversed the ground and the hot, which is the red with the combination of a yellow. But all of them are not ideal. So let us show you how this works. We'll go to a receptacle and really quickly show you how. So let's say we just wire this receptacle. We simply plug it in, and as you can see, we have wired it correctly. We have two yellow lights turning on, and that means that it is correctly wired. And of course this goes inside one of these. This specific one is designed for a retrofit. It has little, I don't know what to call them, not feet. Oh, that's not a retrofit, that's a normal. I thought it was a retrofit. Was it that one that had the little... Okay. There are some ones that for retrofit and they have a little flap that goes just behind the drywall, so you don't have to use a nail to attach it to a stud. Both on top and bottom, you're going to have ports that you can break so your cable can go through. And you just have to work with it until you completely break it off. And now you have an opening for your cable to go through. And again, it has two openings on top and two openings on bottom. And the correct orientation of holes for the plate to attach and for the plug to attach. Make sense? And yes, this actually is for a retrofit, but I think the little feet have fallen off. Because it doesn't have any way to attach it to the stud. So we will have to, one way or another, no matter where we put it, we'll have to glue it. Now, the plastic ones are good, the metal ones are good, it makes no difference. They both meet code. What is important is that exposed wire doesn't come out of this hole. So all your wiring should be inside the hole, And the reason why it is like this is that you can put your circuit through here, and then if you need to continue your circuit, you break the other one, and then a wire comes out of the circuit and continues downstream. Does that make sense, or
Yep.
what does that make no sense?
It's like a little train car. It's
Right.
connected to the next day in line.
So this was our short electrical primer for today. If you want to do your own electrical work, it is not really that difficult. I do want to mention something else. A lot of times, if you have a three-way switch, and a three-way switch is a switch that allows, if you have like a long hallway, and you can turn a light on and off for both sides of the hallway, that switch is a three-way switch. It's called a three-way switch. And those switches will also have a red cable, but it will not be a live cable. It will be a communication between the switch. It's just letting each of the switches, if it is in the on or off position, because three-way switches do not have on and off technically. It depends on what position the other switch is. Does that make some sense? I hope. And now we are for true done. I hope you enjoyed this episode of Basic Electricity at the Urban Homesteading channel. And if you did, please smash that like button. If you didn't, the other button works as well. Share, like, subscribe, and let us know what you want to see in our channel. From the Garage Wizard, Elpida, and the Urban Homesteading channel, we wish you a great week. Happy Thanksgiving. And we're going to see you on the weekend with some type of project. You want to say anything, Elpida? Elpida shakes her head like you guys can see here. Not shakes the camera. So we'll see you soon.